Hello guys and welcome back to my channel Firewall again. In this video we're going to talk about SSL decryption. Yes, SSL decryption is something nowadays we need to use in our organization to decrypt encrypted packet with respect to your different applications. For example, suppose an attacker installs some malware on your HTTPS web servers or a website, and you accidentally visit to that site and unknowingly download that malware. The malware can go to your end system or your laptop, PC, right? And laterally through the network, it goes to different other systems and your entire system get compromised. This happens even though you have a different IPS, IDS, or different filtering in place. When your packet receive or pass from the firewall, that is encrypted, and firewall itself will not see what is in that, right? The packet is encrypted. So to get protection from such things, we need to decrypt that packet. And for that, we need to use SSL decryption. I hope you at least got an idea what is the use of SSL decryption. Nowadays, we hear a lot about it. This is the actual reason. So consider you have IPsec, IDS, whosoever, the SIM tools, whatever integrated in your environment, and you don't have this SSL decryption, then whatever the HTTPS traffic pass from your firewall will not get properly detected. But having the SSL decryption in place, that traffic in depthly can be monitored by IPS, IDS, and get filtered or get protection on this. Mostly URL filterings, what we see in these different firewalls. If we don't have SSL decryption for that, you don't get the proper, the output out of it. Because this SSL decryption not happens, the category you don't know which it is getting followed, and a lot of things happens there. So basically, when I talk about the SSL decryption, it uses keys and certificate to establish a trusted connection with your firewalls. We can use third-party certificate or firewall certificate. Not recommended. We need to use some trusted third-party certificate, which is, say, a VeriSign, GoDaddy, or whosoever is very trusted. We need to get a certificate from them, sign, because externally, if we have something, you will get more protection. Locally, we can have the firewall certificates, which we can use for this purpose, but not recommended. So consider your firewall, next generation firewall decrypts your SSL TLS traffic to the plain text for the inspection. Once that inspection done, the firewall re-encrypt the traffic before forwarding to its destination. It ensures that SSL decryption works with respect to your threat prevention, advanced URL filtering, and rest of the other services, right? Additionally, if I talk about a use cases for the services, for example, uh, you can selectively decrypt traffic based on your categories, which you need to apply a threat prevention or any sort of decryption. Generally the finance or compliance or whatever the sensitive sites or the traffic, we should not decrypt. That is what the norms and the standards what we have in industry, because once that is got decrypted, you will be able to see what is going on with those details, right? So you don't have to decrypt those. That is what generally we don't do in organization. You can see that part as well, but other than that, you can decrypt rest of the traffic just sake of your protection. There is something like SSH decryption also, but you just keep this in mind. SSH is generally we use for the secure connection with respect to your say applications like PuTTY, or taking the device access, something like that. So generally for this thing we don't use the certificates. It's more likely you just have to configure the thing and it works. In Palo Alto, when we configure the high availability, generally the decrypted sessions what we have from the one firewall to the another firewall, that is not get supported. Generally after the failover, your next generation firewalls like Palo Alto doesn't support this HSing for decrypted sessions. So keep this in mind. HA will not give you that much throughput when the things happen or the failover happens and all those decryption things get, happens. When I talk about the keys are like a string of numbers which typically generated using a mathematical operation which involve random numbers, large prime numbers, and based on those calculation the keys get generated. So keys are something which we call like a shared secret or your password, which we generally use to encrypt your in data into the ciphertext, and the key again we use to decrypt. So two types of algorithms we have for the keys. One is symmetric key, where the same key is used to encrypt and decrypt, and asymmetric key, where one key is used for encryption and mathematically related keys, uh, like say public private key, the other key is used for your decryptions. And generally, when we talk about the certificates, it's like X.509 certificate, which we use to establish a trust between the client and server for the SSL connections. Talk more about the structure of X.509 certificates. Uh, it exact identifies your information about the server. I mean, it's like extracts your all the details from the server fields, what IP address you needed, what FQDN you have used. Like for certificate purpose, it's more like a common name, or we call it CA, CN within the certificate. Then your organization details, department details, and all those things. Generally, uh, we have those in a certificate. And there is something which is must, is like your certificate authority. Generally we call it as a CA, which must issue all the certificates. It's like authority which gives you sign to your certificate that okay, this certificate is good to go. So after the CA verifies a client or a server, the CA issues a certificate and sign it with a you know as per his norms, and then the things get processed. So this is what basic things when we talk about the SSL thing. Now let's quickly go ahead and do the lab. So as you can see, this is my topology. Focus on this DMZ part. So we have here, these are the subnet 10.1.2, which I'm going to use for the decryption purpose. and this PC is how it will act and how the traffic is processed. You can see right away now. So from here the traffic will go to the internet. So only on Palo Alto side I'm going to assign this SSL decryption. So checkpoint side will be having some another video, will be doing the same thing, but for now just understand from the Palo Alto side. So traffic will pass from 10.1. say 2.x any PC to the Palo Alto, from there to the checkpoint and then to the internet. All right, for now let's go to the your Palo Alto and monitor, and I'll just generate some traffic for you guys. Let me just go to the Google Chrome, and from here let's go ahead and type something here. Say I want to go to the checkpoint. Okay, so I just go to the checkpoint site. Now let's go ahead and observe the traffic, and here let me just refresh it, and as you can see I have generated some traffic here. This one 10.1.2.30 to this guy, SSL is allowed, and all those things. We need to check it everything from the scratch. Let's go ahead with that. Let me just say if I have Windows machine available right away. Yeah, it is. Let me just save it. Let me just start this machine. Meanwhile, let's just have the connectivity. Save it. Let's go into this machine. Let me just give it a password. So I'll just quickly change the IP address, which will go to same subnet where we're going to apply SSL decryption. So let me just go ahead and type the IP address here. The IP is 10.1.2.60 for now. Subnet mask is /24, and default gateway would be the firewall IP address 254. Let's go to the 8.8.8.8 as a DNS, and it will grab the network. So this looks good. Let me just go ahead and just say I want to go to the Google. Yeah, I'm there. So net is working. Let's go to the checkpoint or a Palo Alto, whatever you like. Just want to go to the site. We are having some traffic here, and it's saying web browsing, something like that. If you notice the source IP address and the destination IP address, what we're trying. All right, so now let's quickly go ahead and create a certificate. So certificate, you need to go to the device, then come to the certificate management and the certificate. You need to generate a certificate here, so click to generate. Give it a common name, so I'd say just for the sake of understanding certificate, and I'll give the IP address. You can use a forward trust certificate option, which generally we use to for your next generation firewall to present a copy of the server certificate signed by forward trust certificate to the client authentication. And forward untrust certificate is like a copy of the server certificate to the client, but it's again the trust certificate is more like the server and client trusted, but untrust certificates is also something which they don't trust each other, but somehow someday you need to use it. And trusted root CA is more of your certificate for the root CA kind of thing. You need to have this option select based on your requirements. For now, I am selecting all. So the certificate is got generated. Now, next thing, I can export this certificate and add into the pieces where I want to have this communication, or I can keep it as it is and try to communicate via this path, and we'll see if the certificate get installed. Next thing, what I need to do, I need to go to the policy, and from here I need to go to this decryption policy, and I need to add it here. So for now I'm adding all networks, so I'm saying decryption for all kind of name. Here I'll give source is any source address, or I would say let's do this. Let's have the DMZ as a source zone. Source address, I would say 10.1.2.0. Rest of the things as it is. Destination, it is going to anywhere, so I'm okay with that. If I want specific, I can give outside as well. So let's for now stick to the outside. Service, for now I'm giving anything, and the option part I'm selecting decrypt and SSL forward proxy. Decryption profile, I don't have any for now, but I can use default for now. It's up to you. Login successful SSL handshake, log unsuccessful handshake, you can go with both. I don't have any log forwarding mechanism, so I'm not selecting anything here. So the rules is also configured. Let's go ahead and do the commit, and let's wait until the commit is performed. So commit is done. Let me close this, and now what we will do, we'll go to the PC. So this one which I have just added. So let me just open this guy, and from here if I do refresh, let's see what changes happens. So right now I'm seeing there is some delay, and now I can see your connection is not private. Attacker might trying to steal your information on all those things. The certificate authority, whatever it is invalid, right? If I go to the advanced, it gives me more details on this. Let's do this. Let's go to the Google, and here also I am getting the same details. If I go to this part, I'll see the certificate. I can see 10.1.2.254 is the certificate cannot be verified up to the trusted certificate authority and all. I can see it's trying to get a certificate from my Palo Alto Firewall, but it's not getting it, right? So now let's see, I can import the certificate here. So the IP address 10.1.2.254. Proceed. Okay, let me just log in to the firewall. Okay, so I just log into the firewall. I just want to go to the device and from there to the certificate, and I just want to download the certificate so that I can install into this PC and I will not get an error what we are getting right now. So as it is, I'm just downloading it. The certificate is here. I just want to install this one, so I'm just opening it and just install the certificate. I want to select a place. Basically, you need to install it into the certificate root certification authority, and from there, as simple as that, you just have to install it. So now the certificate is also imported, and now I'll just go to the Google and type say checkpoint in advance, or let's do this. Let me just go ahead and do incognito mode, and here let's go to the Google. Now I can see the Google is loading without any issue as I have just installed a certificate. Let me just go to the checkpoint, and I can see everything is loaded without any issue. We are not getting any certificate error message right now, right? And if I go to the this secure and the certificate, I can see the issuer is my Palo Alto Firewall. So this is a simple lab I have performed for the SSL inspection. I hope you guys understand few concepts. Okay, so this is a simple lab. I want you to go to the Palo Alto and here go to the monitoring and check the latest logs. For example, latestly I tried this one, and you can see the traffic is getting allowed. And same if I go to the decryption for the same IP, earlier we were not seeing anything, but now you are seeing all the decrypted traffic, right? So the policy name is decryption for all. The proxy type is forward, and all those details you can observe here, right? So guys, I hope you found this video informative, and thanks for watching this video guys, and have a wonderful day.